Solve one problem on static force analysis of 4-bar mechanism by using superposition method.
Let us understand how to draw the diagram as per given data. Here the lengths of all links are mentioned in the question. Link AD is the fixed link and length is 900 mm. So we will draw the diagram with some suitable scale, and we will take scale 1 cm is equal to 50 mm. So how to draw this link AD? So for that 900 divided by 50, and which is equal to 18 cm. So we will take the distance 18 cm and we will draw this link AD. Now angle DAB 60 degree is mentioned. So we have to take the angle 60 degree, and along this line we have to take the length of AB 400 mm, that is 400 divided by 50. So we have to take here 8 cm distance. Now exact location of point C is not given, but the length BC as well as CD is mentioned in the question. So as per this scale, BC is equal to 12 cm and CD is equal to 10 cm. So in compass we will take here 12 cm distance, take B as a center, and we will mark here one arc. In the same way, we will take the distance 10 cm, take D as a center, and we will mark here one arc, and point of intersection is nothing but the point C. So we will join this. Now there is one extra point is mentioned, that is the point E, and whose location is mentioned from this point B as well as C. So BE is equal to 400 mm. So as per scale 400 divided by 50, 8 cm distance we will take, and we will mark here one arc. In the same way, CE is equal to 300 mm. So in compass we will take 6 cm distance, and we will mark here one arc. And this point of intersection is point E. So we will join this. On link CD there is one force acts, and that is equal to 150 Newton, which is at angle of 45 degree, and distance from this point D is 250 mm. So as per this scale 5 cm distance we have to mark here one point, and from this horizontal line take an angle of 45 degree and mark here one force for 150 Newton. Now at point E also 100 Newton force is there, but it is at 180 degree angle. So at point E we will draw here horizontal line, and we will take angle of 180 degree, and this force acts at point E. So we have to show the direction of force towards this point E. So this is the 100 Newton force. Now if we observe this mechanism, here we will consider this section BEC as single section. So we will give the numbers to the link. So here AD is the link number 1, AB link 2, then this whole section BEC as a link number 3, and CD link number 4. So this is the 4-bar mechanism. Now for this mechanism, if we observe, there are two forces, 150 Newton as well as 100 Newton. So we will apply here the superposition method to solve this question. Now what is the question? We have to find out what is the torque is to be applied on link AB. Because of these two forces, 150 Newton and 100 Newton, this mechanism tries to displace from its original position. And to bring the system back into equilibrium, we have to apply torque on this link AB. Now its magnitude as well as direction is not known, and we have to find out its magnitude and direction of this torque T by applying superposition method. Superposition method, we have to split this question into two parts. In first part we have to consider only 150 Newton force, and in second part we have to consider only 100 Newton force. So we will consider the F is equal to 150 Newton on this link CD. Now first step is to identify the types of members. Now if we observe this link AB, then here there are two forces are applied. That is through this point A, F of 1 to 2. through this point B, f of 3 to 2. And there is torque that we have to find out. So we can say that link AB is 2 force, 1 torque member. Now we will move to the link BC. So for this link BC, through this point B, force is applied F of 2 to 3. Through this point C, force applied F of 4 to 3. So this is 2 force member. Now we will move to the link CD. So for this link CD, through this point D, force applied F of 3 to 4. Through this point D, force applied F of 1 to 4. And there is force F1 is equal to 150 Newton. So I will write here force F1, that is equal to 150 Newton. So this is 3 force member. Now second step is to draw the free body diagram. So how to draw the free body diagram? So we have to take the reference for this diagram. Now we will first draw the link CD. So for that we have to take the equal lengths. That is here the length we have to take from this diagram, and in this way with parallel line we have to take the link CD, and that is equal to 10 centimeter. Now from this link CD, at the distance of 5 centimeter there is one point, and then at this point we have to transfer this force is equal to 150 Newton. So again take line parallel and draw here one line, and that is 150 Newton force. Now we will transfer link AB. So in the same way we have to take the line parallel to this AB and transfer here the link AB. Now we have to take the same distance here and we have to transfer this. So in the same way BC is getting transferred. So as BEC is one link that we have to consider, so we will transfer only this link BC. So here we have to transfer this. Now if we observe link BC is 2 force member. So what is the condition for the 2 force member? That is the line of action of force is along that link. So BC is in this direction. So I will show here the line of action of force. So I will show this with the help of red marker. Now through this point C, which force is applied? F of 4 to 3. So this is the line of action of force F of 4 to 3. Now through this point B there is F of 2 to 3. That this force is getting applied. Now if we observe through this point C, there is same line of action of force we have to show for this link CD. So I will transfer this line. Now this is the line of action of force for the link CD. So which is the force is getting applied through this point C? F of 3 to 4. So I will say F of 3 to 4. Now link CD is 3 force member. That means there should be concurrent point. Now how to find out the concurrent point? So this is the line of action of force F of 3 to 4, and this is the second force. So we have to join these two forces, and these two forces meet at this point. So this is the concurrent point. Now the line of action of force, third force, should pass through this concurrent point. So we will join this concurrent point and this point D. Now for this link CD, which is the force is applied through this point D, F of 1 to 4. So I will write here F of 1 to 4. That means this is the line of action of force of F of 1 to 4. Now we have to find out for this link AB. So link AB is 2 force and 1 torque member. So through this point B, if we observe, there is the line of action of force in this direction. So I have to transfer the same line of action of force through this point B. So take the line parallel to this and I will draw here, because this point B and this point B is same. Now for this AB, which force is there? So for link AB, F of 3 to 2. Now here the torque is getting applied, but we don't know magnitude as well as direction. But because this is two force and one torque member, the forces applied on this link should be parallel to each other. That means we can say that the line of action of forces are also parallel to each other. So I will show here the line of action of force for this to this point A, and so this point A, this is the line of action of force of F of 1 to 2. We don't know the direction as well as magnitude for any force. So for this three force member, we will draw the force polygon, and this force polygon should be closed so that resultant force is equal to 0. Now if we observe, this is the line of action of force F of 3 to 4. This is the line of action of force F of 1 to 4, whose magnitude as well as direction is not known. But what about this force 150 Newton, whose magnitude 150 Newton and direction is also known, and that is mentioned in the question. So we will take some suitable scale, and that scale 1 centimeter is equal to 10 Newton. So for this 150 Newton, we will take distance of 15 centimeter and we will transfer this force. That is, we should take the line parallel to this force, and at a distance of 15 centimeter we will draw this force 150 Newton. Now the remaining other two forces we have to draw either at the head or at the tail. So I will select this F of 1 to 4, that is at the tail of this force. So F of 1 to 4, here is the line of action of force. So I have to draw here the same line of action of force passing through the tail. Now this is the line of action of force F of 3 to 4. So we have to pass this line of action of force passing through this head. So we should draw the parallel line. So here is the point of intersection. Now this force polygon should be closed. That means where this, I will say this force is F1, where the head of this force F1, there should be tail of the next force. So here this is the F of 3 to 4. So here at this point there should be tail and here should be head of the force. Now at the head of this F of 3 to 4, there should be tail of the next force. So the next force is F of 1 to 4. So this here should be the tail of this. So this force polygon is closed. Now we get the direction of these forces. So where is the direction of F of 3 to 4? So F of 3 to 4, direction is towards the right hand direction. So we will show here. That is right hand direction. Now where is the direction of F of 1 to 4? So F of 1 to 4 is in the upward direction. So we will show this. Now this F of 3 to 4 and F of 4 to 3 are equal in magnitude but opposite in direction. So we will show here. Now F of 4 to 3 and F of 2 to 3 are equal in magnitude but opposite in direction. So we have to show direction opposite to this. Now F of 2 to 3 and F of 3 to 2 equal in magnitude but opposite in direction. So I have to show direction in the opposite direction, that is here. Now this is the two force and one torque member. So we know that these forces are, that is F of 3 to 2 and F of 1 to 2, equal in magnitude but opposite in direction. So I have to show direction here. Now if we observe this, these two forces form a couple and moves in anti-clockwise direction. So here torque should apply in clockwise direction. So we get the direction of this torque T. Now we will decide the magnitude of the torque. Now in this force polygon we will measure the length of this f of 3 to 4, and this length is equal to 8.5 centimeter. But according to the scale, 1 centimeter is equal to 10 Newton. This f of 3 to 4 is equal to 8.5 into 10, that is equal to 85 Newton. Now f of 3 to 4 is here, that is it is equal to 85 Newton. So we can say that this f of 3 to 4 and f of 4 to 3 are equal, and f of 4 to 3 and f of 2 to 3 are also equal in magnitude, and therefore f of 2 to 3 is equal to f of 3 to 2, and which is equal to 85 Newton. Now we have to measure the perpendicular distance in between these two forces. So how to measure? So with the help of this protractor, I will align one edge with this one line of action of force, and this other edge is the perpendicular line. So if we measure this height h, then this h is equal to 7 centimeter. But this is drawn as per the scale, 1 centimeter is equal to 50 millimeter. So we will take 7 into 50, that is 350 millimeter. But we have to find out the torque in Newton meter. So we will convert this into meter, that is 0.35 meter. So how to calculate this torque? Force is 85 Newton multiplied by this height h, 0.35. So which is equal to 29.75 Newton meter, and direction is clockwise. Now we will move to the second part. Consider force 100 Newton only, and which is acting at this point E. Now first step is to identify the types of the members. So first we will take the link AB. So for this link AB, through the point B, force acting f of 3 to 2. Through this point A, force acting f of 1 to 2. And third is the torque. So we can say that this is 2 force and 1 torque member. Now link BC. So if we observe this third link, so we have to consider this 100 Newton at this point E. So here through this point P, force acting f of 2 to 3. Through this point C, force is f of 4 to 3, and there is force F2. So I will say that F2 is equal to 100 Newton. So this is 3 force member. Now link CD. So for this link CD, this time we are not going to consider this 150 Newton force. So force through this point C, f of 3 to 4. And through the point D, f of 1 to 4. So this is 2 force member. So we will first take the 2 force member to draw the free body diagram. So we have to first draw link AB parallel to this, then link CD parallel to this CD, and for link BC, so this time we have to consider this whole section BEC, and at the point E we will take this 100 Newton force in horizontal direction as mentioned in the question. Now for the 2 force member is the link CD. So line of action of force is along this link CD. So I will show this line of action of force. So through the point C, force is we have to consider. So this is the line of action of force for f of 3 to 4. And through the point D, force is f of 1 to 4. So this is the line of action of f of 1 to 4. Now here through the point C, and here is also point C. So same line of action of force we have to take. So I will take one parallel line. And now this is the one line of action of force. So this is 3 force members. So link BC is 3 force members. So we have to find out the concurrent point. So this is the direction of second force F2. So I will extend this, and this is the concurrent point. Now here is the third point. So for the third line of action of force should pass through this concurrent point. So I will join this point B and this concurrent point. So here we will get the line of action of third force. Now here is the point B. So this is the line of action of which force? F of 2 to 3. F of 2 to 3. And through the point C, which force is applied? F of 4 to 3. Now here is the point B, and for this link AB, here is also point B. So there is same line of action of force. So draw one line parallel to this, passing through the point B. Now for this link AB, which force is there? F of 3 to 2. Now this is AB is 2 force and 1 torque member. So here is the torque whose magnitude and direction is not known. Now if we observe for this 2 force and 1 torque member, the line of action of forces are parallel to each other. So we have to show this. So through this point A, there is force F of 1 to 2. Now we don't know direction as well as magnitude of any force. So for this 3 force member, we will draw force polygon. So this force polygon should be closed so that resultant of all these forces is equal to 0. We will take some suitable scale. 1 centimeter is equal to 10 Newton. Now out of these 3 forces, here is the force F2, whose direction as well as magnitude is known. So magnitude is 100 Newton. So as per this scale, we have to take 10 centimeter distance and direction is towards the right hand side. So here is the head and this is the tail. Now any line of action of force should pass through head and any line of action of force should pass through tail. So we can select any force. So I will select F of 4 to 3. Now I will take this line parallel to, and I will pass this line of action of force through the head of this force F2. So this is the line. So I will mention here this is force F2. Now here is the line of action of F of 2 to 3. So we have to pass through the tail of this line of action of force. So here is the point. Now this force polygon should be closed. That means here we will F of 4 to 3 and this is for F of 2 to 3. Here is the head of F2. At that point there should be tail of the next force, that is F of 4 to 3. So we have to show head at this point. Now here the head of F of 4 to 3, there should be tail of the next force, that is for the F of 2 to 3. So we have to show the arrow in this way. So this force polygon is closed. Now we can easily say that here is the direction of F of 4 to 3. So F of 4 to 3 is in the upward direction. So I will show the direction. And F of 2 to 3. So F of 2 to 3 is having the direction towards the left hand side. So we have to show this. Now F of 2 to 3 and F of 3 to 2 are equal in magnitude but opposite in direction. So I will show here the direction. Now F of 3 to 2 and F of 1 to 2 equal in magnitude but opposite in direction. So here is the direction. Now if we observe, these two forces form a couple and in anti-clockwise direction. So we have to apply the torque and that should be in clockwise direction. Now we will find out magnitude of the torque. So for that we will measure what is the length of F of 2 to 3. So F of 2 to 3 is 10 centimeters. So as per this scale, 10 multiplied by 10, that is 100 Newton. So F of 2 to 3 is here and which is equal to 100 Newton. So F of 2 to 3 and F of 3 to 2 are equal in magnitude but opposite in direction. So it is equal to 100 Newton. So how to measure torque? So for that we have to measure the perpendicular distance in between these two line of action of force. So I will align one edge with this line of action of force and along the second edge I will draw here perpendicular line. So if we measure this h, then h is equal to 6 centimeter. But this diagram is as per this scale 1 centimeter is equal to 50 millimeter. So 6 multiplied by 50 is equal to 300 millimeter, and we will convert it into meter, that is 0.3 meter. So how to measure the magnitude? So torque is equal to 100 multiplied by 0.3, and which is equal to 30 Newton, and direction is in the clockwise. So we will find out the resultant torque. So in the first part we have calculated torque 29.70 Newton meter plus here 30 Newton meter. So both are having same direction, that is in the clockwise. So final answer T 59.70 Newton meter, and it is in clockwise direction.